Hello, Dave Kenworthy here. It's the 13th of the 9th, 2021. And I've had a comment on the previous presentation by Charles Magner. And he's asked me to contact him. And the best way to get in touch with me, Charles, is to sign yourself up as a member for the History of Metrology Tapper Talk website. And once you've done that, we'll be able to talk to each other on that website. So that's the best way to get in touch. Now, Charles has flagged up this metric unit of 0.5184 meters as being a very significant unit. Which it is, and if we convert it to Imperial Inches, we get this unit here, 20.412 inches. There's the millimeters, and that's inches. And let me just tell you what's happening on this spreadsheet. This is Berriman's summary of linear units from page 29 of Historical Metrology, and this is it. And this is the key that turns historical metrology into a science. Metrology at the moment is standing in a very strange place where there's absolutely no interest in it from academia. But if this book is properly read and properly understood, historical metrology is turned into a science, and the design of the Giza pyramid can be fully understood by properly analysing Berriman's work. And the key to it all is on this one page. And I'm going to go through this now, because what is ironic is that Berriman has found this unit of 39.375 inches as the ancient metre. But when he's summarised the linear units in this table, he's used the modern millimetre instead of the ancient one, which is surprising to say the least. And what I've done is I've substituted the ancient millimetre in this table, and it produces some absolutely stunning results. So we're looking at 20.412 here. This is the unit that Charles has flagged, and it's down as 519 modern millimetres. But the ancient version is 518.4, and that's what Charles has flagged. And this is such an important unit. It's 28 digits, a version of the Royal Cubit. So again, we're straight into Berriman's work. And we'll go through the table and I'll explain how it works. But before I do, I need to just let everybody be aware of the fact that this unit of measure is something that Melissa is aware of. There it is, 20.412, coming out of 25920, and there's the calculation that gives 20.412. This is such an important cubit. If you multiply this unit, well, I'll show you on the spreadsheet. We'll go down to it, tag over a bit. If we multiply it by 100 divided by 99, we get this famous Royal Cubit. This is a Berriman cubit, but it's also Michel and Neil. They've found it as a geodetic cubit. Berriman's identified it as a root 2 cubit. So let me just go through this table and explain what's happening. These are all the units with Berriman's notation down the side. I'll slowly go down to the bottom of the table so that anyone watching the video can understand just exactly how many units there are in this table. First thing I want to flag for Melissa is this. UU equals 2U, 21.6. That's what Melissa was asking for. Why isn't it 21.6? Why isn't 2U 21.6? Why isn't U 1.08? Well, it is. Somewhere. There. U 10.8. So what Melissa was asking for is in Berriman's table of measures. Now, he said that these are linear measures, Berriman's summary of linear units, but he also tells us that they were hiding cubic units in linear units, and here is one. That's the Royal Cubit, and that's the metric version, and we've been through this. That's the Giza sphere. Well, 100 Giza spheres. We've already been through that. Now, this is what I've done. I've converted the inches into millimeters using 1000 divided by 39.375. So that is multiplied by 1000 divided by 39.375. But what we notice here is all these units can be multiplied by 7. And the reason for that is 39.375 is a base 7 unit. The underlying design of that unit is base 7. And the reason why it works with the Royal Cubit is the underlying design of the Royal Cubit is base 11, prime 11. So we're dealing with prime 7 and prime 11, and that's why the two units are working together. And we can see here, when you get these trailing decimal places, you know that there's been division by 7. So we multiply by 7. Doesn't work too well with the first one, but then look. The Chinese chi, it's given us 1600 millimeters, and it's 9 imperial inches. So is Berriman telling us that the Chinese were using the imperial inch? Yes, he is. And he does it several times. There's another one there. And this one works brilliantly. Now, I don't know myself how he's got these measures, but we know that he was a top class researcher, and we know that he had access to the best investigation procedures at various places like the British Museum and the Oxford Libraries. He had carte blanche. He could have gone anywhere he wanted to work anything out that he wanted to, and the man was so precise in everything that he does. His punctuation is absolutely top class. Mine is absolutely awful compared with his. But everything that he does is high quality. And this table, it's such a surprise that he's not used his own meter when he's produced this table. Because look at what's happening. 1600, 1920, 1944, that's Greaves Roman foot. 20.7, 20736. That's the base 12 cubit. It's 12 times 12 times 12 times 12, and we get 20736. That's a key unit. Then 2112, we find that at Stonehenge. That's base 99. 2160, 60 times 60 times 60 times 60. 60 times 60 times 60 is that. That one is Chinese. I'm not 100% sure of that. I don't know. I don't know if he's calculated that properly, but it's giving a whole number there, so maybe he has. Now what we've got is inches, then millimeters times 7, and then what I've done in this column is, because the megalithic yard is a variable unit, it can be anything we want it to be. It doesn't have to be 32.64 inches. It's that for a reason. 32.64 inches puts the megalithic yard as a base 17 unit. It's a prime 17 unit. And the megalithic yard is 16 times 17, which is 272. And then we multiply it by 12 to get 32.64. But in the Giza Base, regardless of the length of the megalithic yard, there are always 1111.111 recurring megalithic yards. So if that's a megalithic yard, that multiplied by 1111, there it is, recurring. I can put as many ones on the end of there as I want to. But if we look, it's the same calculation. It's that times 111. These are all megalithic yard. These are all inches in the Giza Base. These are megalithic yards. So 10,000 inches produced by the Chinese Chai. 12,000 produced by you when it's 10.8, which Melissa was looking for. 12,150, 3/4 of a Berrimans, 12 digits, and it's giving that. The Roman foot, 16 digits, 11.664. We're getting that, and we're getting that, which is absolutely stunning. And it just goes on and on all the way down here. And we get to the bottom and we get the Giza Base, because that, Akbar's yard, 25 inches, 50 shoesy, that is the base 100 megalithic yard. And we know it is. And that's it in millimeters. That's it multiplied by 7. And that multiplied by 1111.111 recurring gives the Giza Base in inches. So this is a descending scale up the Giza Pyramid. Every one of these units is part of the design of Giza. And look at these. These are that's the meg yard. And that's the Giza Base in millimeters here. So we're getting meaningful information coming out of the design of the Giza Base when we use millimeters. So we got 576 millimeters there using 20.412. And we've got 3628.8 when we multiply that by 7. And this is exactly what Charles is telling us. He's saying that this is a crucial unit. And he was aware that it was that in meters. I don't know if he was aware that we've got to use Berriman's meter. But when we do, we get this phenomenal arrangement. And there's so much in here. And there's one thing that I particularly want to show you, because I amended one of the units. I wasn't happy with it because I test checked some of the units to make sure that Berriman was calculating them okay. And this one didn't pass the test. And when I corrected it, I got 17.67. Well, you can see that that is a string that's obviously needs to be multiplied by 7. And when we turn it into millimeters, we get that. When we multiply it by 7, we get pi, 1,000 pi of 22/7, which again is a fantastic result for Berriman and a fantastic result for the metrologists that are following Melissa and who are all working in the same direction, starting to use Berriman as the template for historical metrology to be turned into a science. And this table is telling us all exactly what we need to know. And there's Melissa getting it right. So I'm going to stop there, but there's so much more that I could talk about in this table. But I'll leave it for now. So thank you very much.